Elsewhere in this course, I have described how to enumerate the number of possibilities through permutations when the order of things matters. In this movie, I will describe combinations where order doesn't matter. As an example, assume that you have 5 products and you draw from them to create gift baskets or samples for potential customers. So the question is, if you had 5 items and you take 3 and you do not allow duplication, how many possible different combinations do you have? And once again, combinations must occur without duplication. However, in contrast to permutations, order doesn't matter. A gift basket with these 3 items would be the same as a gift basket with the same items, even if they were put into the basket in a different order. So our goal is to calculate how many unique groups are possible when choosing 3 of 5 products without allowing repetition. To demonstrate, I will switch over to Excel. I have opened this movie's Excel sample file, and it is 0606 Combinations Without Duplication. You can find that in the Chapter 6 folder of the Exercise Files collection. This is a fairly straightforward workbook, and you can see that I only need 2 pieces of data. Those are in B3 and B4. Those are the number of available products in B3 and the number of items in a sample basket in B4. So I'll click in cell B6 and I'll create my first formula. Type an equal sign. And I want to find the number of combinations. So in other words, because order doesn't matter, I can use combinations rather than permutations. So I'll make sure that I have COMBIN entered into the formula, and B3 contains the number, that is the number of potential items from which we will select, then a comma, and the number chosen. That's B4, the items in each basket. Write parentheses and enter, and I see that there are 10 possible combinations. If I increased the number of available products from 5 to 8, we would go from 10 to 56 possible combinations, and if I wanted to increase the number of items in the basket from 3 to 4, still leaving 8 available, we would go from 56 to 70. Because order doesn't matter with combinations like it does for permutations, the number of possible combinations increases more slowly than does the number of possible permutations. However, I guarantee that as the number of available products and the number of items in the sample basket grow, the number of combinations will grow very quickly.